And also, like I said, 9.6, and this is solving exponential and logarithmic equations. All right, so we're going to start out solving exponential equations first. And y'all, those are the ones that are in the form of y equals a to the x. So we'll be solving for the variable when it's an exponent in these, okay? So the first thing on these, if it's possible, I want to rewrite each side of the equation using the same base. Because if I can rewrite each side using the same base, then there's a little property here called the base exponent property. So y'all, the base exponent property says if a to the x equals a to the y, then, so they're saying, hey, you got the same bases raised to exponents. Well, if these bases match and this is an equation, then that means the exponents have to be equal so that x equals y. So they're not too bad if we can rewrite them using the same base. But y'all, if it's not possible to rewrite, each side using the same base, then I have to go at it in a different approach, okay? So if I can't rewrite them using the same base, the first thing I'll do is I'll take the LN, the log, or the LN of both sides. And this all goes back to if two sides are equal, if I take the log of one side, then I have to take the log of the other side, okay? And it goes back to what you do to one side of an equation, you got to do to the other. Now, I'll do the LN if it has the letter E in the equation. So that little fancy E, if it's in the equation, I'll do the LN because it makes them easier. All right, y'all. So once I take the log or the LN of both sides, I'm going to use that power rule we learned last week. So using the power rule, I'm going to bring the exponents down. And rewrite as a product. So we did that last week also when we was bringing them exponents down and rewriting them. All right, so once we done that, that variable will no longer be an exponent, it'll be down in the equation. So at that point, I'll start solving for the variable. All right, then the last thing you'll do, no matter which way you go about solving it, the last thing is, if needed, check answers. Okay, so we're gonna play with some exponential first, and then we'll look at steps for solving logarithmic later. So these examples will say solve for x. All right, so we're going to solve for x. So the very first one has 6 to the x equals 36. So y'all, what I do first on this one, I'm going to see if I can rewrite each side using the same base. Now this side has a base 6 raised to the exponent of an x. So what I want to try to do, can I rewrite 36 using 6 with an exponent? And yes, right, if we take 6 times 6, that equals 36. So I had to multiply 6 twice. So that means I can rewrite the 36 as a 6 squared. So let's write that in here. So I got 6 to the x now equals 6 squared. So it was possible to rewrite it using the same bases. So now what you notice, these bases match. Since my bases match, using this base exponent property, it says if your bases match, then the exponents are equal. So since my bases match, that means that the exponent x equals the exponent 2. So final answer. So if I want to check that, I'll put that 2 back in for that x and see if this is true. So 6 squared has to equal 36. That's true because 6 squared is 6 times 6, which is 36. So y'all are not too bad if we can rewrite them. So I'm going to let y'all help me on this one. I got 4 to the 5x equals 16. So y'all, is it possible for me to rewrite that 16 using a base of a 4?
4 squared.
There you go. So that's perfect. So that's going to be 4 squared. So always focus on the base that has that variable and try to match that. So good job. So that means I can write 4 to the 5x equals 4 squared. So you got my bases to match. So that means since our bases match, the 5x exponent has to equal this exponent of 2. Right now, on this one, you actually had to do a little solving. So at this point, solve for the x. And y'all, all we got to do is what? Divide both sides by that 5. So that cancels, and my x equals a 2 over 5. So if we was to put the 2 over 5 in for the x, so let me check that real quick, show y'all how I would do that. I got 4 to the 5th times 2/5 equals 16. Well, the 5's cancel, leaving me 4 squared. And y'all, 4 squared equals 16 does check. So that tells us we got the right answer. So when you check it, that's all you're doing. Just plug back in and see what you get, okay? All right, so questions on these two, y'all. Your only goal is to, on these first two, was to rewrite using that same base as they gave us. So let's see what we do when we cannot rewrite using the same base. So for number 3 here, we got 5 to the x equals 24. And y'all notice this, there's no way I can take a 5 as a base and raise it to an exponent to equal 24. The closest I could get would be 5 squared, but that would give me 25. So this one cannot be rewritten with the same base. So that means I go to step 2 on that list, which said take a log of both sides. So we're going to take log of both sides. So that'll give us a log of 5 to the x equals a log of 24. And y'all remember the whole reason I took the logs of both sides was because I can use the power rule over here. And the power rule tells me to bring that x down to the front and rewrite this as a product. So rewrite the left side as a product. So that'll give you x times log 5 equals the other side, which is a log 24. So now x times log 5 equals log 24. We want to get the x by itself now. So we're going to divide both sides by this log 5. That's going to equal a log of 24 divided by a log of 5. So y'all, what's going to happen? These log 5s cancel, leaving me my x. Now these, since we're taking logs, are going to give me decimal answers. So you always have to round these equations off to 4 decimal places. Now I'm going to show you this one on the calculator, but when you do the calculator and punch this, when you punch log, it's going to give you an opening parenthesis. So put in a 24, then close the parentheses, and then hit the divide button. When you hit the log on the bottom, it's going to give you the opening parentheses. So then you just got to close it on the 5. So once you put a number in with a log, you got to close those parentheses. All right, y'all, so let's look at this and see what we're about to round this thing off to, going 4 decimal places. So the log's on the front, so hit log, punch in your 24, close parentheses, hit your divide, and then you're going to do a log, so hit log again, put in the 5, and then close the parentheses. So see, when I hit log, it all actually gives me the first parentheses. All right, y'all, we're rounding this 4 decimal places. So that looks like a 1.974. So the 6 has a 3 after it, so we're going to keep that as 6. So we get 1.9746. So that's what you got to watch for when you're doing these on the calculator, that you're shutting those parentheses, okay? All right, y'all, let's see. Number 4 has 3 to the 9x minus 5 equals 81. So remember my first step. So y'all, let me ask y'all this. Could I rewrite this 81 with a base of a 3?
Would it be yes?
What'd you just say?
Would it be yes?
It'd be a yes, definitely. Because that's got a bunch of 9s, and guess what? Them 9s all have a bunch of 3s in them, right?
Right.
So we're going to rewrite 81 as 3 to what power? So let's see. We know 3 times 3 is 9, so that's 2 of them. 9 times 3 is 27, so that's 3 of them.
4th.
20, yeah, because 27 times 3 gives me 81. So we'll rewrite this as 3 to the 4th. So our 3 to the 9x minus 5 equals 3 to the 4th. So good job. I think it's easier to do these than coming through and doing all these logs. But y'all, guess what, man? The bases match. which means the exponent 9x minus 5 equals this exponent of a 4. All right, so like we did a while ago, now it's time to solve for my x. So let's see, we'll add our 5, that gets to 9x by itself. So doing that, I got 9x equals 9. And then y'all, to make that a 1x, we're going to divide by the 9. So that cancels, giving me my x. This cancels, giving me a 1. All right, y'all, let me let some in real quick. All right, then you put the 1 back in there, you would see that that actually checks out and makes that true. All right, y'all, here we go. 3x, 3 to the x power equals 5. So can we rewrite a 5 using the base of a 3?
No.
No.
No, so we cannot rewrite. And y'all, since we can't rewrite, we're going to do like we did here. We're going to take the log, because our goal now is to get that x brought down. And the only way to do that is to take those logs. So we're going to take log of both sides. So I got the log of 3 to the x equals the log of 5. And guess what? Now that gives me the power to bring my x down to the front using the power rule. So I can rewrite the left side as a product. So that'll give me x times log of 3 equals the log of a 5. And y'all look, the same thing I did here, I'm going to divide both sides by the log multiplied by the x so that I can cancel this side out. So divide both sides by log of 3. So that cancels, my x is now by itself. And once again, we're going to round this to 4 decimal places. And don't forget on the calculator to shut those parentheses. So if any of y'all got a calculator? Y'all want to see what you get on that?
1.4650.
Oh, wow, you rounded that off and everything. Good job. Because I think that had, what, a 4.9 something? So you had to round a 9 and a 5. Good job. So they're not too bad. It's just you can only approximate these to ever how far they want us to go, okay? All right, y'all. This is a tricky one right here. I got 10 to the negative x equals 8 to the 5x. So this one's sort of tricky because you got the variable on both sides. And y'all, guess what? I don't think I can rewrite neither one of these numbers as the other one's base. So this one we cannot be rewritten. Which means we're going to jump in and take the log of both sides. So y'all, that'll give me a log of 10 to the negative x equals a log of 8 to the 5x. All right, so our real goal now is to bring both of these exponents down because I can't solve them while they're exponents. I got to bring them down into the equation. So this left side will give me a negative x log 10 equals a 5x times the log of 8. So all we did was bring exponents down and rewrite that as a product. So here's where the dilemma starts happening. I got an X on this side and I got an X on that side. I need to get all my X's on the same side. So what I'm going to do, I'm probably going to move this one over here because it's negative. So I'm going to add a X log 10 to both sides. Okay, because remember, since the X's are on both sides, we need them on one side so that we can start solving for these X's. So this side, negative X log 10, positive X log 10, at the moment, that gives me a big 0. Now the right side, they're not like terms, so I'm going to keep that a 5X log 8 plus a X log 10. Now y'all look at this. I got an X in this term and an X in this term. So we're going to sort of do a little bit of factoring to that. So let me bring down my 0. I'm going to factor out a greatest common factor on the right side. So since they both have an X, I'm going to factor out an X as the greatest common factor. Now, y'all remember, if you factor out an X in the parentheses, you take both of these terms, divide them by the X, and put what's left in here. So if I got a 5X log 8, I divide by the X, that's going to leave us what? A 5 log 8. Then we got a plus. And y'all, what about that second one? I got an X log 10. If you divide that by the X, what's left?
Log 10.
Good job, log 10. So now, and y'all's number 6 will probably get the same answer I get on mine because I've done this a lot and it's always giving us the same answer. But now we got X times all this stuff in the parentheses. We're going to divide both sides by these parentheses to get that X by itself. So on the left side, I'll have 0 divided by 5 log 8 plus log 10. That's going to equal the right side. X times 5 log 8 plus log 10. Divide that side by the 5 log 8 plus the log 10. So those are going to cancel, leaving me my X over here. Oh, and y'all look at this. 0 divided by anything is going to give me a 0. And y'all, that's the same answer I've gotten no matter how many times I've done this problem. So y'all probably going to get y'all 0 on that number 6. But that makes sense. If you put a 0 here, 10 to the 0 is 1. You put a 0 here, 5 times 0 is 0. 8 to the 0 power is 1. Remember, anything to the 0 power equals 1, so that does check out, okay? All right, let's see what I got next. All right, so let me turn my paper over. It's starting to fold. All right, so number 7, this is when I'm going to start using the LN because I got an E to the T equals 153. So y'all, I'm not going to try to rewrite that 153 using the base of an E, okay? So I cannot rewrite. So since I cannot rewrite, I'm actually going to take the LN of both sides. So remember, take LNs when you got the E, because you're going to have an LN of E to the T equals an LN of 153. Now, y'all recall one thing here. the ln of e to any exponent equals what? Now remember, ln means log base e of e, right? So this would really be log base e of e to the x. In the long run, when your base of the log matches the base of the result raised to an exponent, the answer is always that exponent. Okay, so anytime you get something like this, that's why we do the ln, because the ln of the e raised to an exponent of t, this side is just going to equal t. That's going to equal whatever the ln of 153 gives us. Well, that's going to be rounded off to 4 decimal places. So y'all got a calculator, y'all can punch me in a ln of 153 and round me out about 4 decimal places.
5.0304.
Looks good, good job. All right, so same type problem. This one is an e to the negative 0.87 t equals 0.89. And y'all, same situation, right? I can't rewrite 0.89 using the e. So our first move, take the ln of both sides. So y'all, I got an ln of e to the negative 0.87 t. That's going to equal the ln of a 0.89. So what will the left side give me? Well, y'all remember, the ln is a log base e, so that e matches that log base raised to an exponent. Remember, the answer is always the exponent. So the left side is just going to give us a negative 0.87 t. So we're still using this property right here on those. And now that equals ln of 0.89. So here we got to solve for the t. And it looks like we just got one move, right? We're going to divide both sides by that negative 0.87. That's going to equal the ln of the 0.89 divided by negative 0.87. So since I'm going to have to round this, it's got an ln in it. So y'all, remember, all right, push this one in and shut them parentheses on that 0.89 before you divide and see what you get on that.
.1339.
Good. So we know you're pretty good at rounding, right? All right, so here comes the last of the exponential. I got 6 to the x equals 3 to the x plus 1. So y'all, we cannot rewrite. Now, since this don't have the e in it, I'm just going to take logs of both sides. So I got the log of 6 to the x equals the log of 3 to the x plus 1. All right, we did that because we're going to bring some exponents down to the front. So I got an x times log 6. Now, y'all, since this exponent has 2 parts, you need to put that x plus 1 in parentheses and then multiply by the log 3. Because remember, you're rewriting it as a product here, and that x plus 1 is getting all of that multiplied by that log 3. All right, so now we want to solve for x. So the first thing you would do is get rid of parentheses by multiplying the log 3 times everything in those parentheses. So the left side will stay at x log 6. X times log 3 gives you an x log 3 plus 1 times log 3 is just 1 log 3. So y'all remember there's an imaginary 1 in front of that log, okay? All right, so we're still trying to solve for x, but look here, the x's are on both sides. Now this one does not have an x, so what I need to do is get all these x's on the same side. So let's subtract x log 3 from both sides. So watch what happens. I get an x log 6 minus x log 3. That's going to equal, the only thing left over here now is a log 3. So here's my question for y'all. I got an x in this term, x log 6. I got an x in this term, x log 3. How can I turn those 2 x's into 1 x? All right, so check this out. Anytime you got the variable in 2 different terms and you want to pull it out as 1 variable, you always want to take the greatest common factor because they both have an x in common, right? So you want to factor out that x and then put everything else into parentheses. So if you factor out an x of the first term, you're going to be left with the log 6 minus, you factor the x out of the second term, you're left with a log 3. All that's going to equal log 3. All right, so if you remember a while ago when we did this with the t's, I got x times parentheses. I'm going to divide both sides by the parentheses. Because remember, my goal is just to get the x over here by itself. So if I divide both sides by a log 6 minus a log 3, they cancel out over here, leaving our x. Now, y'all here, watch what you got to do to put this one in the calculator. You got to close the parenthesis around all these logs. But since the bottom has 2 parts, you got to put extra parentheses around that bottom when you do this on the calculator, okay? That way it knows that this is your whole denominator. So you got to do log 3, close parentheses, divide, open parentheses for the bottom, log 6, close parentheses, minus log 3, close parentheses, and then close the main parentheses for the bottom. So y'all want to attempt that one?
1.5850.
Ooh, go. There you go. 1.5850. All right, so y'all, that's a trick. When you got the logs and the LNs left in the answers, you will have these decimal approximations, okay? So y'all, that takes care of the exponential equations. Next, we'll start with some logarithmic equations. So now we're solving logarithmic equations. All right, so the first thing you got to do, if you got more than one log on either side, you need to combine logs on each side if needed. Now, when we say combine logs, we mean write as a single log. So this is the stuff we did in 9.5. If they were being added, I wrote them as a product. If they were being subtracted, we wrote them as a quotient. All right, so the second thing, do we have a log base equal to a log base? Because if we do, we got a little property called logarithmic equality. And it's sort of like that base exponent property we just looked at. This one says if I got a log base A of m equal to a log base A of n. So if the bases of these logs match up, then m equals n. That means the two results are equal if the log bases match, okay? Now, if not, then we have to rewrite it as exponential. And we sort of learned that last week. Once I rewrite them as exponential, I will then solve for the variable. Now, if you could write it as a single logarithm, and then you have the log base equality, you would skip this step as exponential, and you would go straight to solving for the variable. And then remember my last step, check if needed. So let me ask y'all something. Do y'all remember last week we had a few problems where it said use your calculator to evaluate the log, and they gave you a log of a negative number? What happened when you took the log of a negative number? Well, if you push that on your calculator, if you did like a log of a -2, say, calculator should give you an error message, remember? So when we try to take logs of negative numbers, we said those do not exist. So if we get negative answers, we got to throw those negative answers out because we can't take the log of negative numbers, okay? So remember, cannot take logs of negative numbers. So that was the does not exist stuff. Which means if I get negative answers, I'm throwing them out, okay? All right, y'all, so here we go. We're going to solve for x. So my number 10 has log base 4 of x equals 2. All right, it's already a single logarithm. There's not a log on both sides, so I won't be able to get the log bases equal to each other. So I'm at this step, rewrite it as exponential. So I'm going to rewrite as exponential. All right, so my base is 4. My exponent is 2, and the result is x. And y'all, one step to be done is we just got to figure out what 4 squared is. So let's see, 4 times 4 is 16 equal to my x. So if you put a 16 in here, log base 4 is 16. The exponent I would raise 4 to be 16 would be that 2. All right, log of x equals -5. So we only got a single log on one side, so we're going to rewrite as exponential. Y'all, what's my base? Because they do not have a base here.
10.
Did you just say what?
Isn't it 10?
It's 10. Exponent is -5, and 10 to the -5 equals x. So if you do this on a calculator, you should get a 0.00001 equal to your x. So negative exponents, remember, give you decimals or fractions, okay? All right, y'all, let's see. This is what, number 12? Log base 6 of 4x minus 4 equals 4. So I got a single log again, so I'm going to rewrite as exponential. So we got a base of 6 on this one. Exponents to 4, and that's going to equal 4x minus 4. Well, all right, y'all. So what's 6 to the 4th power? That'd be like 6 times 6 times 6 times 6. I think that equals what
1,296.
and that's going to equal 4x minus 4. So at this point, we're just solving for our x again. So it's right here. So let's add 4 to both sides. So that's going to give me 1,300 equal to my 4x. Let's divide that by 4 and see what we get. Well, that cancels, giving me my x. Oh, that's what, 300 and something.
325.
325. There you go. All right, 13. Now they're going to up it and give me a few more steps on it. So this one has a log x plus a log x minus 21 equals 2. So since I got 2 logs over here, I'm going to combine logs. Since they're being added, we rewrite this as a product. So we'll have our log of our x times x minus 21 all equals 2. And y'all, I'm going to go one more step, and I'm going to distribute that x to see what that gives us. So we got an x times x is an x squared. X times -21 is a -21x. All this equal to 2. So I'm combining it as a product and actually sort of multiplying it out. Now rewrite this as exponential, because we're down to a single log. Whoops. So there's no base again, which means it automatically becomes a 10 exponent of 2. And that's going to equal the result, x squared minus 21x. All right, so y'all, we can do this. What's 10 squared?
100.
I think the others must be asleep on the same thing. All right, so here's what happens. Since that's got an exponent of 2 on that x, we got to solve this using factoring or quadratic formula, which means you need a 0 over here. So I'm going to subtract 100 from both sides. So I get a 0 equals x squared minus 21x minus 100. Now, if you got the quad formula, you can do 1, negative 21, negative 100 in the quad and get the answers. I'm going to factor it. And you'll notice that on all these log equations, they're pretty much going to be negative on the last number, which means these will have unlike signs. So y'all give me some factors of 100 that'll subtract and get me that 21. So let's see, you got 1 times 100.
25 and 4.
Okay, so good job. You got your so the 25 will be negative at this point and the 4 positive. Now remember, solve both of these by setting both factors equal to 0. So y'all we're going to subtract 4. I get x equals negative 4. I'm going to add 25 to the second one. And I get x equals a positive 25. So y'all, what is my final answer? Because remember, at this point, you're checking your answer, remember. And this says I cannot take logs of negative numbers. So that negative 4 is negative. So if you try to take log of negative 4, it's going to give you an error, which means I cannot keep that negative answer. And the only answer is the positive 25. Okay. So y'all
Can
watch
you
for that
table
on
up a
the,
little bit?
like this.
Yes, sir. Thank you.
Okay. And y'all, you're on a log, you got to throw down negative ones away, okay? Now, if you'd have put it in it, if you'd have put it in up here at quad, it would have gave you the negative 4 and 25. So just keep positive 25. All right, y'all, let me see here. I'm gonna fix my paper again. All right, so we're on 14. Now 14 is going to have logs everywhere. So let me come back up. 14 has a log base 3 of t plus 16 minus a log base 3 of t plus 7 is going to equal a log base 3 of a t. So we need to start out by this side combining the logs. Now, since these are being subtracted, this one needs to look like a quotient, like division. So bring down your log 3. The positive goes to the top. That's the t plus 16. This one's being subtracted, so the t plus 7 goes to the bottom. That's going to equal the log base 3 of t. So look what I got. I got a log base 3 on the left side. I got a log base 3 on the right side. The log bases match. So since the log bases match, this result, t plus 16 over t plus 7 is going to equal this result, which is a t. So y'all watch this. We got t's everywhere. So the easiest thing I thought on solving this one is make the t look like a fraction, and I'm going to cross multiply. So top times bottom equals top times bottom, okay? So the t plus 16 gets multiplied by 1. Well, t 16 times 1 is a t plus 16. That's going to equal this t plus 7 multiplied by the t. Now, both of these got to multiply by that t. So you got a t times t is a t squared plus 7 times t is a 7t. Oh, look at that. We got a t squared, which means we really need a 0 over here equal to our equation. So to move the t over, I'm going to subtract a t from both sides. I'm going to subtract a 16 from both sides. Because both of these need to move over here so that this side is a 0. So let's see what goes over here. We got our t squared. I got positive 7 minus 1t, which gives me a positive 6t, and then bring down that negative 16. So y'all, it is time to factor again. I got a t and a t. Last sign's negative, so I got unlike signs again. Now you could hit it with the quad right here, 1, 6, negative 16. So here's the question. What factors of 16 equals 6?
10.
8 and 2.
So 8 and a 2. Good job. All right, the rest of this is just setting these two factors equal to 0 and solving. So y'all, what I'm going to get looks like a negative 8. And I'm going to get a positive 2. So the final answer would be
2. T equals 2.
yeah, you got to cancel that one out. So then we just get our 2. Good job. All right, log base 4 of x plus 1 minus log base 4 of x equals 3. All right, so we need to combine logs on the left side. And y'all, they're being subtracted, so they're going to look like a quotient again. So I got on top the x plus 1, the factor of x is being subtracted, goes to the bottom. That's going to equal 3. So now, since I only got one log on this one, we're going to rewrite as exponential. So my base is a 4, exponent is a 3. That's going to equal the result of an x plus 1 over an x. So I probably would, first step would be to change that 4 to the third power. That'd be 4 times 4 times 4. Multiplying that out, you're going to get a 64 equal to the x plus 1 over x. And y'all, guess what? I'm going to put a 1 under that and cross multiply. So the 64 multiplies by the x, which gives me a 64x. That's going to equal 1 times x plus 1, which will be 1 times x is x, plus 1 times 1 is 1. So look here, we got to get the x's on one side. So since I got an x and a number over here, I need to move this x to the side with the x over here. So I'm just going to subtract the x from both sides. So 64 minus 1 will leave me 63 x's. Those cancel, leaving me just my 1. Oh, y'all, looks like we're going to get a fraction here because we now need to divide both sides by 63. So the 63's cancel, leaving my x. Cannot do nothing to that, so that's going to stay 1 over 63. Okay, y'all, so The trick up here, remember, just start out by getting those logs combined. You'll either have the situation where you get a log on both sides, or you'll get a situation where you got one log and you got to rewrite that as exponential, okay? All right, y'all, so we're getting close. 16 coming up. I think there was only like 17 in this section. So log base 3 of x plus log base 3 of x minus 1 equals the log base 3 of a 6. So left side, we got to combine logs. They're being added, so this will look like a product. So bring down your log base 3. The product will be the x times x minus 1. All that's going to equal log base 3 of a 6. And y'all, if you remember a while ago, let's multiply this and get this out of the way. So bring down that log base 3. X times x will be an x squared. X times -1 is a negative x. All that's equal to the log base 3 of a 6. So y'all see what happens on here, right? I got a log base 3 on both sides and they match. So my log bases match. So this result, x squared minus x, is equal to this result of a 6. Now we got the x squared again, so this 6 needs to be a 0. So I need to subtract 6 from both sides. So I get an x squared minus the x minus the 6 equals 0. And y'all, now it's time to what? Factor this. So let's see what we can factor this one into. We got an x and an x. That's negative again. So unlike signs. So you notice on all these with the logs, if they're having to be factored or hit with the quad, you're throwing one of these answers away every time. So y'all, I need some numbers. What factors a 6 will subtract and give me a 1?
3 and 2.
So let's see, the 3 is negative and 2 is positive. Good job, and they equal -1 like the middle. So now let's just solve these by setting them both equal to 0. But y'all, if you can get them factored, then you can say, well, that is going to give me -2, that is going to give me +3. So throw that in the way, because that's all I'm doing here is changing signs when I set each of them equal to that 0. So I get a -2 here. +3 here. So once again, y'all, there's that negative answer we cannot take. And the only answer is our x equals 3. And y'all, the last one coming up. Log base 3 of x plus 12 plus a log base 3 of x minus 12 equals 4. And if you notice, they're sort of alternating back and forth between having the matching log bases. And this one, since I don't have a log on the right side, we're probably going to have to rewrite as exponential. So the first thing I'm going to do on the left side, I'm going to combine logs. Now they're being added, so we rewrite this as a product. So we got our log base 3. We'll have the x plus 12 times the x minus 12. All this equal to 4. And y'all, I'm going to go one step further. I'm going to FOIL this real quick. But remember, these are conjugate pairs. So I'm going to shortcut FOIL. So bring down that log 3. So when you shortcut FOIL, x times x is x squared. And then you do the numbers. 12 times negative 12 is a negative 144. All this equal to 4. Y'all, you're going to get the shortcut for y'all's also, okay? Because it's either going to be 12s, probably 7s, 8s, whatever number, it's going to match, okay? All right, so I got a single log. So now this one, I got to rewrite as exponential. So my base is a 3. My exponent is a 4. And that's going to equal that result of an x squared minus 144. All right, so we got that 3 to the 4th. Well, if you remember a while ago, y'all had to write a certain number as 3 to the 4th. So y'all, what does that 3 to the 4th equal?
81.
So I got 81 equals x squared minus 144. Now I want to show you a trick on this one. Over here, I had to factor this stuff because I had the x term. We don't have an x term here. So watch what I do. I'm going to add 144 to both sides. That's going to give me 225 equals my x squared. So this one I can solve by taking square roots of both sides. So I'm going to take square roots. So the square root of 225 equals the square root of x squared. Well, I know the square root of x squared is going to give me an x. What's the square root of 225?
Plus or minus 15.
Well, good job. Plus or minus 15. So since we got the plus or minus, that means x equals 15. X equals negative 15. But guess what? We're going to cancel out that negative 15, and our only answer will be the positive 15. So y'all, that's exponential and logarithmic equations. Remember, your goal on exponential is to rewrite them using the same basis. If you can't rewrite them using the same basis, then you got to take logs or LNs so that you can bring them exponents down. Logarithmic, you hope that they got logs on both sides so you can use that log base property. But if not, rewrite them as exponential. And no matter what you do up top, most of these you had to rewrite as exponential, okay? The only time you didn't is when we had these log bases matching up and we was able to do the result equal the result. So y'all, that is 9-6. So all we got left is what is it? 9-7. And that one we're going to learn a formula. And I'll show you the formula we'll learn. So to use this formula for like population growth and decay, like radioactive decay. They can also use it for investments that have continuous compounding. So the PO, when we learn it, will be the initial amount we start with. E, that's Euler's number. K will be the growth rate or the interest rate or the decay rate. T will be time, and then P of T will be the amount at that time. So it's similar to the interest problem we did, but instead of having all that in the middle, remember the 1 plus R divided by N, they use the E, okay? And then K is your growth or decay rate. And that's all we got left to play with. So we'll play with that when we hit 9.7 Wednesday. So y'all, let me ask y'all, do y'all have any questions?
Will there be a review for the next test?
Oh yeah, so here's the thing. We'll do 9-7 Wednesday. Then y'all got Thanksgiving break next week, right? So what we're gonna do when you come back from Thanksgiving break, we're gonna review for test 4 that Monday. And even that Wednesday, if we got any to review left, we'll do that Wednesday. That next Monday will be our last day of class technically, because that's the week finals will start. So that last Monday, we're going to review for the final. Now, I might start reviewing for the final next Wednesday after we come back. It just depends on how much we got to do with this test 4. I think test 4 had 25 questions. So the test is going to be exactly like that study guide. Now, a lot of the problems are pretty quick because you're just using the calculator. Find me the log, blah, blah, blah. But there are a few equations on it, okay?
Okay.
So we definitely want to review for that test and then for that final. And y'all, that's pretty much all y'all got left with me, right?
Yes.
All right, so let me stop this recording.